Okay, with number 20, we have the integral from 0 to 1 of square root of x plus 16. So here we have a simple case of function composition, and the derivative of the inside function is a constant, or it's just 1, so it makes it fairly straightforward. So if we let u be equal to the inside function of the function composition, we have u as x plus 16, du is simply dx. We still do need to swap out our limits of integration. So when x is 1, u would be 17. When x is 0, u would be 16. And so we have the integral from 16 to 17 of square root of u, which we'll just call u to the 1/2 du. And we're ready to roll with that. So we're going to increase by 1. We get 3/2 u to the 3/2 times 2/3, and 16 to 17. Not pretty numbers, but so we have 17 to the 3/2. Now 17, there's nothing we can do with that, because 17 is prime. Remember that a rational exponent is power over root, so that is really square root of 17 to the 3rd power. We'll get back to that in a second. 16 to the 3/2, we can take the square root of 16, which is 4 to the 3rd power, so this is just 64. 17 to the 3/2 is 17 square root of 17. And so we have 2/3 times 17 root 17 minus 64. So it looks a little like a, but we're missing the 2/3 there. So what are we going to do here? Well, if you take a look at the answer responses, if we were to distribute the 2/3, we'd end up with 34 over 3 times the square root of 17. That looks sort of like answer D. Then we would have 2 times 64, which is 128 over 3 for the second term, and that is answer D. So that will do it for this problem.